Some important definitions for the concept of reflection. Light, it is an agent which produces in us the sensation of sight and it is a form of energy. Transparent medium is a medium through which light can be propagated very easily. Translucent medium is a medium through which the light is propagated but partially. The opaque medium is a medium through which light cannot be propagated at all. Reflection is the property of light by which light is sent back into the same medium from which it is coming and after being obstructed by a surface. Going on to the concave mirror. It is a spherical mirror which, when looked from the reflected side, is depressed at the center and bulging at the edges. It is a spherical mirror which, when looked from the reflecting side, bulges at the center and is depressed at the convex mirror. It is a spherical mirror which, when looked from the reflecting side, bulges at the center and is depressed at the edges. What is radius of curvature, that is R? It is defined as radius of that sphere of which the mirror forms a part. Principal focus. Principal focus is a point situated on the principal axis at which a beam coming parallel to the principal axis meets or appears to meet after reflection from the mirror. Focal plane. It is a vertical plane passing through the principal focus and perpendicular to the principal axis. Focal length. Focal length of a spherical mirror is the distance of its principal focus from its pole. The relation between the length and the radius of curvature is given as F is equal to R by 2, where F is the focal length and R is radius of curvature. This signifies that focal length of a spherical mirror of its radius of curvature is half. Mirror formula. It is given as 1 by F is equal to 1 by V, which is plus 1 by U is equal to 2 by R. The relative positions, size and nature of image as object is brought from infinity to the pole of a concave mirror. First case, if object is at infinity, that is u is equal to infinite, then v is minus f and m is equal to 0. Thus the image is formed at the focus and very small in dimensions. Case B, if object lies beyond the center of curvature. Then 2f is greater than v and it is greater than f. Case C, if object is at center of curvature, then v is equal to minus 2f and where m is equal to 1. Thus the image is real and inverted. It is of same size as that of the object and it is formed at the center of curvature. Case D, when object is in between distance f and 2f, that is in between focus and center of curvature. Here v is smaller than infinite and m is given as v divided by u, which is greater than 1. Here the image formed is real, inverted and magnified. It is formed between center of curvature and infinity. Case E, when object is kept at focus, that is u is equal to minus f, there v is equal to minus infinity. The rays after reflection are rendered into a parallel beam meeting in infinity. Case F, object is kept within the focus, that is u is smaller than minus f, then v is positive and the image formed is virtual, erect and magnified. It is formed on the other side of the mirror. Some important points to be noted here. In case of spherical mirrors, focal length is half of the radius. Second, in case of concave mirror, a real object produces a real and inverted if its distance from pole is greater than the focal length. while it's virtual and erect if the distance from pole is less than the focal length. Third, in case of convex mirror, a real object always produces a virtual and erect image. All real images are inverted and virtual images are always erect. Moving on to the phenomenon of diffraction. Diffraction is the phenomenon by virtue of which a ray of light going from one medium to the other undergoes a change in its velocity. The incident ray is the one which approaches the interface. The refracted ray is the ray which goes into the second medium and is known as the angle of incidence. The refractive index of a medium with respect to another is defined as ratio of sine of angle of incidence to the sine of angle of refraction, that is sine I by sine R Refractive index of medium 2 with respect to 1 is also defined as the ratio between velocity of light in medium 1 to the velocity of light in medium 2. That is, refractive index of a second medium with respect to first is defined as the ratio between absolute refractive index of second medium to the absolute refractive index of the first medium, and it is given as total internal reflection. Consider a medium R. Here the incident ray, or we can say the critical angle, is the angle of incidence of a ray of light in a denser medium such that its angle of refraction in rarer medium is 90 degree. The total internal reflection is the phenomena by virtue of which a ray of light travelling from a denser to a rarer medium is sent back in the same medium provided it is incident on the interface at an angle greater than critical angle. It is given as mu is equal to 1 by sine C, where C is the critical angle. Refraction at a single spherical surface when light travelling from medium of refractive index mu1, that is rarer, to the denser medium, that is mu2. Here let's consider case A, where refraction at a convex surface produces a real image, that is mu2 upon V is equal to minus mu1 upon U case B, where refraction at a convex surface produces a virtual image, is given as mu2 by V minus mu1 upon U, which is equal to mu2 minus mu1 upon R. Case C, where the refraction is at concave surface, it is given as mu2 upon V minus mu1 upon U, which is equal to mu2 minus mu1 upon R. The refraction at single spherical surface when light travelling from medium of refractive index mu2, that is denser, to the refractive index mu1, that is rarer. Convex surface producing a real image of a real object is given by mu2 by U minus mu1 divided by V, which is equal to mu2 minus mu1 divided by R. Now the light travelling from air to glass is given as mu1 upon V minus mu2 upon V minus mu1 upon V, which is equal to mu1 minus 1 divided by R. The light travelling from glass to air is given as mu upon U minus 1 upon V, which is equal to mu minus 1 upon R. The principal focal length. Second principal focal length is defined as the focal length of a surface, which is the distance of that point from the pole of the surface at which a beam coming parallel to principal axis meets or appears to meet after refraction through the surface. It is given as F2 is equal to mu2R divided by mu2 minus mu1. The first principal length is of a surface that the distance of that point from the pole of surface from where if a beam diverges or to which a beam converges, the rays after refraction through the surface become parallel to the principal axis. It is given as F1 is equal to minus mu1 r divided by mu2 minus mu1. The relation between F1 and F2 is F2 divided by V plus F1 divided by V is equal to 1. Lens. A portion of refracting material bound between two spherical surfaces is called a lens. The converging lens is said to be converging if the width of the beam decreases after refraction through it. The diverging lens is said to diverge if the width of the beam increases after refraction through it. Center of curvature. Center of curvature of a surface of a lens is defined as the center of that sphere of which that surface forms a part. Radius of curvature. Radius of curvature of a surface of a lens is defined as the radius of that sphere of which the surface forms a part. Lens formula. It is given as 1 divided by f, which is equal to 1 divided by v minus 1 divided by u. The linear magnification is the ratio between the size of the image to the size of the object. That is, where I is the size of the image and O is the size of the object. Expression for M in terms of U, V and F can be given as, first, in terms of V and F, in terms of U and F, position of the image as the object is gradually moved from infinity to the pole of lens. First, when object is at infinity, then V is equal to F. Magnification in this case is extremely small, that is M is very small, and the image is real and inverted. When the object lies beyond 2f, then 2f is greater than v, which is in turn greater than minus f. The m is given as v by u, which is less than 1. When the object is placed at 2f, v is equal to 2f and the magnification is less than 1, that is minus 1. When the object is lying between f and 2f, v is greater than 2f and the magnification is always greater than 1. When object is at f, then v is infinity and magnification is infinite. when object is lying between F and C, that is the optical center. At F, the U is minus F, therefore V is infinity. When it is at C, that is optical center, U is 0 and V is also equal to 0. Refraction through a thin double convex lens when the medium on the two sides of the lens is same, that is lens maker's formula, is given as 1 by F, which is equal to mu minus 1 into 1 divided by R1 minus 1 divided by R2. The refraction through a thin double convex lens when the medium situated on the two sides of the lens is different. The formula is given as 1 upon F mu 2 3 minus mu 1 divided by mu 3 R1 plus mu 3 minus mu 2 divided by mu 3 R2. The double concave lens when the medium situated on the two sides of the lens is same. The formula is given as 1 by F is equal to mu minus 1 upon R1 minus 1 upon R2. When the medium situated on the two sides of the lens is different, the formula is given as mu 3 minus mu 1 divided by mu 3 R1 plus mu 3 minus mu 2 divided by mu 3 R2. To keep in mind, this is for the concave lens. The combination of two convex lenses in contact, the formula is given as the power of lens it is the reciprocal of the focal length of a lens expressed in meter, and it's called the power. The formula for it is given as 1 upon F. The refraction through a prism is given as mu is equal to the dm is the minimum angle of deviation. Refraction through a prism for small angle of incidence is given as this signifies that the angle of deviation d is independent of the angle of incidence provided it is small. Dispersion. Dispersion is the splitting of light into its constituent colors Refraction through a prism the first one is deviation. A ray of monochromatic light, that is the light possessing one wavelength only, while passing through a prism suffers a change in its path. The phenomenon is known as deviation. It is given as d is equal to mu minus 1 upon a. Here a is the refractive angle of prism and mu is the refractive index of the material of prism for that particular wavelength of light. Second phenomenon is dispersion. A ray of light that contains more than one wavelength while passing through the prism splits up into a number of rays. The phenomenon is called dispersion. It is given as here d is deviation for violet and dr is deviation for the red color. Mu v and mu r to be the refractive indexes of the material of prism for violet and red colors. Dispersive power, that is denoted by omega. It is defined as the ratio between angular dispersion to mean deviation produced by the prism. It is given as the spectrum. The band of colors lying side by side is called the spectrum. There is impure spectrum and pure spectrum. Impure spectrum is a spectrum in which the constituent colors overlap. Pure spectrum is a spectrum in which all the constituent colors occupy different and distinct positions. Optical instruments. The power of a concave lens is given as where x is the distance of how far point of the defective eye in centimeters. The magnifying power or M of simple microscope is given as 1 plus d upon f. D is the distance of distinct vision and f is the focal length. The magnifying power of compound microscope is given as L upon f0 1 plus d divided by f0. Here f0 is the focal length of the object and fe is the focal length of eyepiece and L is the length of the microscopic tube. Magnifying power or magnification of astronomical telescope in normal adjustment. It is given as M is equal to F0 upon Fe. The magnifying power of astronomical telescope in when the final image is formed at a distance of distinct vision. It is given as the magnifying power or magnification of Galileo's telescope is given as f upon small f.